Alright guys, so today what I'm going to do is I'm going to show you some tricks. We got special factoring trinomials. Remember, a trinomial, it has 3 terms. So what we're going to do is we're going to look at the difference of 2 perfect squares. We're going to look at a perfect square trinomial and the difference of 2 perfect cubes and the sum of 2 perfect cubes. So remember, your standard equation for a quadratic is ax squared plus bx plus c. Okay? So the first one that we're going to look at is the difference of 2 perfect squares. So perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. So the way that we know that they're perfect squares is when we take the square root of them. So if I did like the square root of 81, I would get 9. So I'm going to get some type of whole number. Okay? So factoring the difference of factoring the difference of squares formula is x squared minus y squared equals x plus y parentheses times x minus y. So whenever I know that I have a difference of 2 perfect squares, I'm going to have ax squared plus bx plus c. The first thing that I notice is I'm missing my b, and that it's going to be a subtraction problem. If it hits those 2 things, then I know that, and that they're perfect squares, then I know that I can apply my perfect square, or difference of perfect square formula. So step 1, you square root the first term. Step 2, you square root the second term. And then step 3 is you write your plus minus. So the answer to step 1 plus the answer to step 2 times the answer to step 1 minus the answer to step 2. So here we go. We go m squared minus 16. So first thing I look when I compare it to my standard equation is I'm definitely missing my b, and it's going to be subtraction. And I know that 16 is a perfect square. So let's follow our steps. So we would take the square root of m squared, which would be m. Then I would take the square root of 16. This is step 2, which would be 4. Then I set up my 2 parentheses, and I go plus minus within my parentheses, and then I just plug in what I just found. So m plus 4, m minus 4, and I'm done. This is a lot easier than 6.3. Okay, so let's try another one. So I've got t squared minus 81. So first thing that I notice when I look at this problem is that I am missing my b, and it's a subtraction problem. So I take the square root of t squared, which is t. Then I take the square root of 81, which is 9. Then I set up my 2 parentheses, and I will write a plus minus on them. And I would go t plus 9, t minus 9. And there's my answer. Okay, so I've got x squared minus 16 over 25. So even though I'm dealing with fractions, it shouldn't be too intimidating. First thing that I notice is I've got 2 terms instead of 3, and I'm missing my b, and it's a subtraction problem. So I take the square root of x squared, which is x. Then I take the square root of 16 over 25, which is 4 over 5. I go and I set up my parentheses. I go plus minus, and it's x plus 4 over 5, and x minus 4 over 5. And then I'm done with it. Alright, so I want you to pause the video, and I want you to see if you can do this one by yourself. Alright, so if I have 49x squared minus 25, first thing I notice is that I am missing my b, and that it's a subtraction problem. So I'm going to take the square root of 49x squared, which will be 7x. Then I take the square root of 25, which is 5. I set up my parentheses. I go plus minus 7x plus 5, 7x minus 5, and then I box my answer. Okay, if I look at this one, I've got x squared minus 10. So I notice that my b is missing, and it's subtraction, so let's go ahead and try it. So I take the square root of x squared, which is x, and then I take the square root of 10. But is 10 a perfect square? It's not. So there's no answer for this. So what we would say is the answer is prime. Alright, for f it says x squared plus 36. I notice that I'm missing my b, which is good, but my problem here is that it's an addition problem. It's very easy to rush through these problems and see that you have perfect squares and take the square root, but please, please, please make sure that you pay attention that it is a subtraction problem, because if it's addition, your answer is going to be prime. Don't let that confuse you. Alright, so now we have 50x squared minus 32. When I initially look at this problem, 50 and 32 are not perfect squares, but they're both even, so that tells me that I can pull out a GCF. So if I can pull out a 2, 50 divided by 2 is going to be 25x, minus 32 divided by 2 is going to be 16, and I definitely know 25 and 16 are going to be perfect squares. So I go 2, and then the square root of 25x squared is 5x. The square root of 16 is going to be 4. So I go and put my parentheses. I go plus minus 5x plus 4, 5x minus 4, and I box my answer. So that is the difference of two perfect squares. Hopefully you feel pretty comfortable with it. Alright, now what we're going to deal with is a perfect square trinomial. So a perfect square trinomial is when I have x plus y parentheses squared, so I have a binomial squared, and it equals x squared plus 2xy plus y squared. Or it could be x minus y parentheses squared equals x squared minus 2xy plus y squared. Alright, so the signs right here tell me the signs right here. So those are used interchangeably, and it's always a plus the last one. So what you're looking for is three terms. The first and the last term are going to be squared, and you have an even coefficient in the middle term. So what that means is your b is even if you're looking at ax squared plus bx plus c, which is your standard quadratic equation. Okay, so with a perfect square trinomial, this is going to be super important when we get to chapter 9, especially in 9.3 when we're completing the squares. So I need you guys to start to feel comfortable with this after the notes today. So your steps to find the perfect square trinomial: the first thing that you want to do is you want to take the square root of the first term. The second thing you do is you take the square root of the third term. This is the most important step. Make sure that you show it. Plug your answer in from 1 and 2 into 2 times x times y to check the middle term, because my middle term, or my b, is even. So we always have to multiply it by 2. Then you write the answer with answer to step 1 plus or minus the answer to step 2. And remember, the plus or minus is the sign is whatever the sign is between the first and the second term. So if it's positive, you're going to write positive. If it's negative, you're going to write negative for your final answer. So let's do this. So we have k squared plus 20k plus 100. First thing that I notice is I have three terms. My first term and my last term are going to be perfect squares, and my middle term is even. Okay? So I go through my steps. Step 1 is the square root of the first term. So the square root of k squared equals k. Step 2 is the square root of the last term. So I take the square root of 100, which is 10. Step 3, most important step, is I'm going to go 2 times step 1 times step 2. And that is always how it's going to be. So 2 times 10 is 20k. And I go and I check it with my middle term, and it absolutely checks out. If it checks out, then I write my binomial squared. I look at my between my first and second term, it's positive, so I go plus and then I just plug in k and 10, and I'm done. Alright, let's look at the next one. So we have x squared minus 24x plus 144. First thing I notice, I have three terms. My first term and my last term are perfect squares, and my middle term is even. So it could be a perfect square trinomial. Step 1, take the square root of x squared, which is x. Take the square root of 144, which is 12. Now I've got to check it. So I go 2 times step 1, which is x, times step 2, which is 12. And 2 times 12 is 24. So 24x, I see if they match each other. They absolutely do. The sign doesn't matter. It's just looking at the coefficient, so what that number is. Okay, so I go my binomial squared. I look right here for my term if it's going to be positive or negative. Between the first and the second term it's negative, so this has to be negative. And I plug in x and 12, and I'm done. Hopefully you feel like this is a lot easier than 6.3. 6.3 is definitely the hardest part of the chapter. Okay, let's try another one. So we got 25x squared minus 30x plus 9. Okay, I see I have three terms. I see that these two are definitely perfect squares, and my middle term is even. So first thing I got to do is I got to take the square root of 25x squared, which is going to be 5x. Then I take the square root of 9, which is going to be 3. Then I have to check it, so I'm going to go 2 times 5x times 3. 2 times 5 is 10. 10 times 3 is 30. So this is 30x, which that matches. So I go a binomial squared. I look at my signs. It's minus, so I put minus. And I have 5x minus 3, and I'm done. Okay, so the next one that I have is 36a squared plus 20a plus 25. First thing that I look at, my first and my last term are perfect squares, and my middle term is going to be even. So, and I have three terms, so it's a perfect square it could potentially be a perfect square trinomial. So I'm going to take the square root of 36a squared, which will be 6a. Then I take the square root of 25, which will be 5. And then I got to check it. So I go 2 times 6a times 5. And 2 times 6 is going to be 12. But 12 times 5, does that equal 20? It definitely doesn't. It equals 60a. Okay? So, because these don't match out, this is not a perfect square trinomial. But you're not done with the problem just yet. What you have to do is, now this is in a does not equal 1. So this is section 6.3. And if that works out, great. But once you do the math, you'll see that this doesn't work out at all. So it will be prime. But on your test, if your perfect square trinomial doesn't work out, you need to make sure and either do a equals 1 or a does not equal 1, depending on what it looks like. Alright, the last type of perfect square trinomial that we're going to look at looks like this. So we've got 18x to the third plus 84x squared plus 98x. Alright, first thing that I notice is I want it to be in this form, ax squared plus bx plus c. But if I look at my first exponent, it's x to the third. So that definitely tells me that I'm going to pull out a GCF. Okay, so for 18, 84, and 98, I see that they're all even, so I can pull out a 2, and I've got to pull out an x. So 18 divided by 2 is going to be 9x squared, plus 84 divided by 2 is going to be 42x, plus 98 divided by 2 is going to be 49. So once I pull out my GCF of 2x, then I can see that I have 9x squared plus 42x plus 49. Alright, so I have three terms. My first term is a perfect square, my last term is a perfect square, and my middle term is even. So let's check and see if it will work out. So I take the square root of 9x squared, which would be 3x. Then I take the square root of 49, which will be 7. And then I go 2 times 3x times 7. To check it, 2 times 3 is 6, and 6 times 7 is definitely 42x, which that completely matches. So I bring down my GCF of 2x, I set up my binomial squared, I see that it's positive between the first and the third term, so I put a positive, and I go 3x plus 7. And that is my answer. Alright, so that's your perfect square trinomial. So the last thing that we have to deal with is the sum and the difference of two perfect cubes. Okay, so this time you're going to have two terms, but both of your terms are going to be cubes. Okay, so you have x cubed plus y cubed equals x plus y times x squared minus xy plus y squared. Or you can have x to the third minus y to the third equals x minus y times x squared plus xy plus y squared. Alright, so whenever you have cubes, you're going to have some type of binomial times some type of trinomial. So what you look for is you look for two terms, and each term is a perfect cube. So what we need to do is we need to figure out what our perfect cubes are. So we're going to write those out really quickly. And I would highly suggest before you start this homework assignment that you write out all your perfect squares and you write out your perfect cubes. Okay, so 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 to the third, or 4 times 4 times 4 is 64. 5 times 5 times 5, or 5 to the third, is 125. 6 times 6 times 6 is 216. 7 times 7 times 7 is 343. 8 times 8 times 8 is 512. 9 times 9 times 9 is 729. And 10 times 10 times 10 is 1000. Highly, highly suggest putting these at the top of your homework, and when you take your test, put them on top of your test so that you can, so that you don't have to really think about it too much. Okay? So steps to find the sum or the difference of two perfect cubes. What you do is you take the cube root of the first term. So you're going to take the cube root of the first term. So how you would enter this in your calculator is you'd put whatever your base is, then you would do an up arrow, and then you would do 1 divided by 3. Okay? Then you're going to take the cube root of the second term, and then you're going to write your answer with. So, excuse me. So remember, we have to have a binomial, and then we have to have a trinomial. And what I want you to think of to help us with our signs is SOAP. And SOAP stands for same, opposite, always, positive. So if you remember SOAP, then you're going to set up your signs just fine. So we know that it's going to be a binomial. That's going to be a plus or minus. It's going to be the same or opposite. I'm sorry, it's going to be the same, or it's going to be the opposite, and then it's going to be always positive. I promise when we get going with it, it will make more sense. Okay? So what you write right here is you go step 1, and then you go step 2. For your trinomial, you go step 1 squared. And actually, I would probably put that in parentheses. Then you would do step 1 times step 2. And then you do step 2 squared. Okay, but you want to remember same, opposite, always positive. Okay, so before we start the next one, I know it's already there, but what I want you to do is I want you to cross out this, because we're going to talk through it, and I guarantee if you can talk through it, then you're going to be a-okay. Alright, so I've got x to the third minus 216. So the first thing I notice is I have two terms, and one of my terms is definitely going to be a perfect cube, and I see that 216 is a perfect cube as well. So what I want to do is I want to take the cube root of x to the third, which is just going to be x. Then I'm going to take the cube root of 216, which is going to be, I'm sorry, right here. So how you would enter it in your calculator is you go 216, up arrow, 1 divided by 3, and that will be 6. Now, whenever you have the sum or difference of two perfect cubes, what you want to do is you want to set up your binomial, then you want to set up your trinomial. Okay, and the word that you want to think of is soap. Same, opposite, always positive. Alright, so for same, we're trying to match whatever our original equation is. So this has to be minus. Opposite, so opposite of negative is positive, so I got plus. And then always positive is just going to be plus. So then after that, we can plug in. For our binomial, it's just going to be the values that we just found, x and 6. For a trinomial, it's going to be x squared, then x times 6, and then 6 squared. I need to see this step. If I don't see this step, you will not get full credit. So the last thing we have to do is we just have to clean it up. So I go x minus 6 times x squared, x times 6, so plus 6x, plus 36, and I'm done. Alright.